partitioning schemes we can use. The first of which is known as the DOS partitioning scheme. You guys probably heard that. DOS, I can't write it. Disk operating system, Microsoft, or whatever, invented this scheme a long time ago. I assume it was invented by Microsoft. I don't know. That's where DOS came from. But the theory behind DOS partitioning is the original specification for this DOS partitioning scheme said you could have up to 4, you could partition a disk up to 4 times. That's it. So you could, whatever, 4 partitions. Then in a later release of the specification, they said, well, why do I have that constraint? What if I want more partitions? And so they re-released the specification for DOS partitioning, and it said, all right, well, you can have 4 primary partitions once again, but if you want to have more partitions, you can take one of those primary partitions, you can make it an extended partition, and then inside of that extended partition, you can do a bunch of logical partitions. So there are some words that we need to be aware of then, and I don't know how I would draw that, but I would say if I'm drawing my disk like this, so these are all primary partitions. If I want more than 4, then I could take one of these primary partitions and I could make it an extended partition, and inside of that I could carve that up into various logical partitions. All right, that's what that says. Logical partition, blah, blah, blah. Unlike primary partitions, logical partitions must be contiguous, meaning next to each other on disk. Thanks. There is a finite number of logical partitions, and okay. And I might ask you a question on test. 15 partitions total if you're using a SCSI disk, 63 on an IDE disk. Okay, the other thing we need to know about devices, and I'll get back, well, sometimes this is also known as MBR. If I don't talk about the MBR in another slide or 7, then remind me. And the new partitioning scheme is known as GPT. And if I don't get to that by the end of these slides, remind me and we'll talk about that. Okay, so when we are mounting disks, we need to understand device naming conventions. So if I'm plugging in an IDE hard drive, which no one uses anymore, right?
Hopefully not.
Hope not.
Okay, so I'm not, but and maybe you've heard that term for IDE hard drive. Let's just look at an image search for a second. Oh, that was a good one. Let's go back here. So really, IDE just refers. There we go. Refers to the way that you connect to the hard drive. So if you look there was like this ribbon cable that connected to this hard drive. Yuck. And that's IDE hard drive. But pretty much an IDE hard drive would show up in your device list after you plugged it into Linux. It would show up as /dev HDA if it was the first IDE hard drive, HDB if it was the second hard drive, up to HDD for the 4th IDE hard drive.
The best way you can use an IDE hard drive is by utilizing the disk trays as frisbees and the cable as jumper wires.
Yes.
Best
I like
utilization of that technology.
So the device themselves, and yes, this is really old school. We don't really need to know this, but it does let us understand how we refer to drives nowadays. So we could take like dev HDB, and then we could carve it up into partitions using the DOS or master boot record partitioning scheme. So dev HDA1 would refer to the first partition on our first hard drive, IDE hard drive. SCSI drives or SATA drives show up similarly. And if you look at this, if you know that, so here's like a SATA drive, basically just a different way of connecting to that hard drive. And most of your solid state drives are going to be what, SATA, I guess?
There's either SATA or the M.2.
And that too.
Okay,
What's in that too?
It's,
It looks like a tiny little, like,
it's a little small.
PCI connection.
how do you spell it? M.2?
M.2.
You just slot them in your motherboard, they're great.
Oh, that, okay.
Oh, yeah, so they are solid state, right?
Yeah,
Mhm.
they're
Okay.
wonderful.
They look like a stick of gum.
Their read and write speeds are awesome.
They're my
They're like
favorite.
2,000 megabytes a second.
Well,
Wow.
there's also the M.2 PCIe ones.
Those ones are even better,
Yeah.
but they cost
That's-
even more.
Those are like,
There's
So I don't know what those will show up on your, I bet on a
They
Linux
show the
system.
same.
they show the same
I'm
SDA.
pretty sure
That's
it's
how I have it
SDA,
set up here.
yeah.
Oh, cool. So, but similarly then, our new hard drives then, whether it's SCSI or SATA or M.2, should show up like this, like you have dev SDA for your A refers to your first hard drive, SDB your second hard drive. And then I could carve those up, so my third partition on my first SATA hard drive would be SDA 3. So I think it's important that we know those naming conventions, and you will get familiar with that really quick as we do our partitioning assignment. Some tools that we will make use of, a couple of them maybe. Parted, FDisk, SFDisk, and CFDisk. In fact, in this class, I pretty much just use CFDisk. It's been around longer and I've used it more, but you could use any of those to create our partitions. Okay, so once we've created our partitions, we have to decide what kind of data it's going to hold. And we have to go in and format it with blocks on it or lay it out the way that we want. So there's a lot of different ways in which we can format a disk. Maybe you've heard of some of these. ext3 was the old Linux format. ext4, that's kind of the current Linux file system format. NTFS, that's the Windows file format or partition format. VFAT, we might use this for flash drives or cameras, very minimal type systems. FAT by itself was kind of the old Windows or old DOS file system. And then there's others. Mac uses like HFS or something. Yeah.
Have you ever used ZFS?
Yes. Yep. There's a lot of other newer, fancier ones. ZFS, Ceph, what's the other one we use? ClusterFF. Anyway, there's a lot of other cool.
So I'm reading that ZFS is a lot of overhead, but it also has a crazy amount of data protection
Mhm.
built in.
Like built-in redundancies
Yeah.
and that sort of thing. Some of those are harder to set up. We're not gonna do that. But in my file systems class, we do some. So in the ext file system, since that's the one we're gonna use, that's one of the ones we're gonna use, data is organized for the OS in, and presented, well, I don't know why I said that, but we create, once again, we're laying out what the file system is gonna look like. One of the first components of the ext file system is a component called superblock. And the superblock is actually written a couple places on the partition, and it just has information about the other normal blocks. Okay. Yeah. The ext file system tools. We will use that top one, mkfs minus text4. That will format a partition as an ext4 file system. Mount command, that plugs it in to our directory tree. Unmount, that ejects it from our directory tree. And tune2fs will allow us to modify different file system parameters for ext. And we're probably not going to use the tune2fs command, but it's there. The other things that I want to spend a minute on, which I don't know, did we talk about inodes in IT-1100? Good, okay, well, we'll review this just a little bit. In an ext file system, our file system is made up of inodes. Well, what is an inode? An inode is a number, well, a component of that is a number, I guess. But the inode itself contains metadata about a file, such as the size of the file, the device ID, the UID and GID, other stuff, but interestingly, the inode does not store the file name. Okay, so inodes contain metadata about a file. So if we look at this command df -i,